All right. Well, good morning, folks. Love these chilly mornings now. I like fall. Boy, that 100-degree stuff is too much. Start with my sweatshirt. I'll lose it in a couple hours, right? So, review day, excuse me. Morning congestion, start talking. It's review day. We have, really, if you work your way through the option, it's always optional. Reviews never get graded, but if you work through that online review, that's really going to prepare you well for what to expect on the test. The test is really built out of homework questions, just like what you've done out of Martinich Math. In fact, it's built out of the same types of questions. The program asks a different question to every person, but with slightly different numbers. It's just the way it's programmed, and it generates that unique question for each individual. And the test is actually going to do the same thing. It takes those exact same programmed questions, pick a couple out of this section, a couple out of this section, and puts them together in this test for you. I think there were 18 of them, 18 questions. You sort of the things to remember, just watching, checking participants here. You get all day tomorrow to do it, but you only get 1 hour once you start. Once you click that start button and open it up, you've got to click submit within 1 hour. Now you can, pause, I think, if I recall the program, and come back to it all. In fact, you can look at it all and then work it all out on paper and then go in and type all your answers in, just like a Martinich Math question, homework question, and then click submit. And then you need to send me your on-paper scratch work. You need to do a little something for every problem. Just write it down. If that's all it takes, write it down and show me your answer on paper and send it in just like you would homework. And then I compare your official answers to your scratch work. It allows me to give you some partial credit if you made some little mistake, but ideally you got most of it right, took a wrong turn someplace. If you don't show me any work, you're only going to get 50% of that question. That's kind of what we've all decided here in our department, is that you've got to show us some work and not just, gee, where did you get that answer from? Not just type your answer in. So you got to send in your scratch work. Once I've got that, then I will grade them all. I will grade them. I'll probably start, as soon as I start seeing them come in tomorrow, I'll try to get on it so that you will get your grade back as quickly as possible. I mentioned in this morning's little message, just because I have to do that, there's a good chance I won't be completely done by Wednesday morning Zoom class, but probably just a little later on Wednesday, I'll have everything done. But, so we'll really try to turn it around in a day or less. Okay. Maybe you just start right there. Are there questions about procedure or process for the for the test tomorrow? Anybody have questions about how that's supposed to work? How that's going to work, what you have to do? All right. I think actually the first test question is kind of like an honor question. I agree to not get any outside help or use my book or anything like that, and do my best all by myself. You do get to use your calculator just like you've been doing all along. But what can we say? It is sort of honor system that you're doing your own work, right? And then you work your way through those questions. And all right. Well, how about then contents, those kinds of questions? Do you have something specific you'd like us to go over more this morning, right now? Can we do some more of this kind of question or that kind of question? And
I do.
good. Let's see. Let me see if I can figure out who's talking.
It's Tara.
All right, Tara. Hi.
Hi.
You moving off my bean screen. There you are. Okay. Yeah, sure. Please go ahead.
Can we work on negative fractions again? Multiplying multiple negatives.
Yep. Okay. So I think I'll start from, just makes up some things to begin with here. And so multiplying and dividing with fractions, the signs work just the same way as they do with integers or whole numbers. If I have a negative number and I multiply it by another negative number, negative times negative, just like the integers, excuse me, negative times negative is going to result in a positive number. So if you're dealing with a succession of multiplications or divisions, you can just whether it's fractions or whole numbers or whatever, you could just sort of figure out how many negatives are being multiplied together and figure out what the sign is going to be after that. So just because those are both negative, this is going to be a positive number. Multiplying, you get to multiply the numerators together and you multiply the denominators together. I usually recommend looking to see if there's anything you can cancel and simplify beforehand. Now I just made up one that doesn't have anything canceled out, so this would be 3/10. And just double check, is that in lowest terms? You will be expected to reduce your fractions to lowest terms. Yep, no common factors between a 3 and 10, so you're done there. If you happen to have opposite signs, right? Opposite signs, just like again whole numbers, that means your product will be a negative number. Negative times positive, whatever else happens, I know that's going to be a negative number. In this case, I made up one here. I could divide both of those by 4s. All right. And so now I think I've simplified as much. 7 times 10, 7 times 5, 2 times 5 is a 10. But anyway, and this time, oh, that was supposed to be my negative sign. I used it as my fraction bar. Oops. There's my negative 7/10. Okay. Excuse me. A couple other kinds of things. Oh, need my erasing cloth again. Excuse me. Here we go. Again, whether it's an integer or a fraction, if I'm going to put an exponent on that value, I need to know whether that negative is part of what's being, say, squared or cubed or higher power, or if it's not part of the number that we're raising to a power, but it's after the fact, after I do that squaring, for instance. So here we usually have sort of the difference between negative 5 squared and the negative of 5 squared. And I kind of said it in the way that describes the difference. This is negative times negative, which is a positive 25. This one means square the 5 and then make it opposite. So this is negative 25. And whoops, come on. See? And this would be the same situation. If I had, this one was in here in including the negative, square the 2 and square the 3 and get 4/9. And it is negative times negative. So it's positive. I have this one. This means square that number and then make it negative. So this one's negative 4/5. Still, I mean, you asked about multiplying and dividing in signs, and so I'm kind of just going down the road with that. If I have a division problem with fractions. Remember, we never divide directly. So we have to turn division into multiplying by the reciprocal. So this is the same as, it's always the number after the division sign that you're changing. You're going to turn it into multiplying by the reciprocal of that number. Reciprocal, simply, generally, you think of it as flip it over. And now I'm going to multiply those two things together. I could get 12/10, but here I notice I could divide those both by 2. and get 6/5. An improper fraction bigger than 1, that's fine. Just leave it like that. You'll see instructions that say, leave it as a proper or improper fraction. Don't try to make a mixed number out of it. We haven't been concerned with that. If either of these had been a negative, right, one negative sign, I'll just put one out in front like this. Then we still have negative divided by positive, which means that result is negative. Opposite signs is negative. If they were both negative, it'd be negative divided by negative is positive. Am I doing the kind of thing that you're asking for? You want me to practice a little more? Or something a little more specific?
You got it.
Got it. Okay. Along these lines. So I'm going to make up something here. How about an evaluation problem? And I think I'll put a square on that. Okay. Let's evaluate this expression when x equals a negative. Let's see. I'm going to say 2/3. And y equals, going to make it messy, is it? Messier than you might expect. I don't know, 4/5. Okay? Blah. So an evaluation problem where you have to see what number you would get for this thing if you plug those in for the x's and the y's, or whatever letters are in that problem. So first step then is to just plug it in, plug those numbers in instead of the variables. With previous examples, when I always did a negative number, I always put them in parentheses because it's going to be next to something else. I want to think of that as a negative number and not a minus. And especially here where I want to put my x's in, x has a negative sign. I need that parenthesis to say that's a negative number and not 3 minus 2/3. And then, especially since I'm going to end up squaring that, minus 4 times 4/5. So here I'm evaluating this expression. Now it's an order of operations problem. What am I supposed to do first? There's no real groupings, nothing inside of parentheses to simplify. Next level is always exponents. Any exponents? Yes, exponents right there. I'm going to square the 2/3. Negative 2/3 times negative 2/3 will be positive 4/9, right? And now I have 3 times 4/9 for that first piece. That took care of the exponents, and I won't even do anything else yet, okay? Here I don't really need those parentheses. I just kind of have a habit of wrapping the fraction up. It doesn't hurt to put the parentheses around it, right? Like here, I didn't. I just used the multiplication dot. Took care of the exponent. Now I'm down to multiply or divide. Yep, a couple of those there. Here I can think of this as like 3/1, right? Any whole number or integer, think of it as a fraction over 1. 3 times, well, how about I do this, huh? I'm going to cancel those 3's. So that becomes 4/3 minus, I'll do the same over here, 16/5. A little bit of everything, I guess. Now I have to get a common denominator, huh? Well, no common factors. I'm just going to have to use a 15 for the common denominator. If I'm adding or subtracting, they got to be the same size pieces. Got to have the same denominator. So we build the equivalent fractions. If I multiply the denominator by 5, I get there. And so I have to do the numerator also. And times 3 gets me there. So here I have 20/15 minus, that's a 48. Now here's maybe a situation, I'll finish this up, right? Is that negative 28 over 15. And now, like I've said before, for add and subtract, you don't know if you're going to end up with something in those terms or not. Be sure you double check. That's built out of 3's and 5's, and this is 2's and 7's, right? So nothing to cancel. We are done. What was I about to say otherwise. Hopefully it'll pop back in my head here in a second. Thought it was important to finish that. Okay, let's see, 20/15 minus a 48/15. And, oh well, you know how it is. If it's important, it'll come back to me in a second. So evaluating like that, so plugging the values in and seeing what you get. Again, a version of, I made it out of fractions, so made it a version of multiplying and dividing, and then some add and subtract also. Kind of went off on my own a little bit there. How about something else? Specific. Oh, I gotta let somebody in. Here we go. Good. Oh, hello, Maria. So, good. Any other specifics? Something else you'd kind of like me to do? Otherwise, then I'll kind of start making stuff up. All right. I see that several of you have worked through the review already. That's great. There's that second optional review. It's a handout from one of our other teachers had developed that for their class some time ago. Sometimes when I look over it, sometimes there's problems on there that seem a little harder than what we do these days. And well, if it really looks like something we've never covered, then it's possible we don't cover that anymore. Nicely that handout has answers in the back of it also. I thought maybe it'd be good to look at a couple of these translation kinds of problems. You know, here's this phrase, and we need to write the correct algebraic expression. Now let's see. I've got my version of that review, that optional review that you've got. And let's see. Sum of a cube of a number. Where did it go? And two times the number. And you're asked to change this phrase into an algebraic expression. That usually involves a variable and then some other operation that affects that variable. If we're going to add or subtract something or multiply that variable or maybe raise it to a power like this one suggests. In this case, well, in general, you're not always going to be told which thing in this phrase is the unknown or the variable, but that's kind of what a number, vague, blank, you know, what's a number? That's the variable, that's the unknown. And here it is again, the number. So whichever variable you're using, it's actually going to show up twice in this expression, like two parts that have that variable in it. And so what are we asked to do to this expression? Well, the sum of, so we're going to add two things together. All right, that's like the first part. We're going to add two things, whatever they are, we're going to add two things. Or maybe it's three, I suppose, but usually two. A cube of a number and 2 times the number. Well, the and kind of separates the two different parts, right? A cube of a number. Well, the number is what we don't know. So a cube of a number, I think my problem said use an x. Watch out for that in the test. You know, it said use this variable, you better use that letter. A cube of a number, that's that exponent 3, and 2 times the number. 2 times the number. Somehow, you know, folks sometimes mess that one up and they try to say like x plus 2 for 2 times the number. Times means multiply. So 2 times the number, I'd say 2x. That would be my translation. I'll keep going unless you slow me down, okay? And There was one, maybe I saw it over here that looked kind of weird. It's like, oh. Oh yeah, I think this was on the other handout. Easier to write the number, the digit than the word. 3 less than the quotient of a number and 5. Right, so it's like, oh, it sounds like there's maybe like 3 different things going on. 3 less, a quotient of a number, and a 5. Well, 3 less than. This is kind of like that previous one that says the sum of, and here come the parts. This is 3 less than, okay, whatever the rest is that's coming, I'm going to put a 3 less than. How do I write 3 less than that? I'm going to put a -3 after whatever comes before it. 3 less than that. The quotient of a number, oh, there's my variable, and 5. The quotient. What's the quotient mean? That's a division problem. 3 less than the quotient of a number and 5. Well, this is worthwhile. Just thinking about, oh, how would I have to type that into Mon, right? 3 less than the quotient of a number and 5. I could do the quotient of a number and 5. That's x divided by 5. There's one way to write that. So I kind of stretched it out there. Let's make that look a little better. Or I really could do, my open math would follow order of operations. Here I could say x divided by 5 minus 3. Order of operations, I think, would interpret that properly. If you have any doubt, sometimes I put that in parentheses, I know that's a group, one thing all by itself. And that's what comes after it. That'd be real clear, but I'm pretty sure if they let you use, I don't even think you can use that division symbol in my open math. All right, you'd have to do x divided by 5 minus 3, and it'll interpret that correctly for you. I'm thinking of, well, let's worry about it later because it's a little more complicated and you're not going to be asked to do it right now. I won't mess you up with harder than you need right now. You guys feel okay about those kinds of things, or should I do more of that? Again, just chime in. It's like, see what you think. So, what else? Simplifying expressions using order of operations. Now, I kind of made up one a minute ago that had some fractions in it, but we've done a variety of that kind of operation. If it just has a bunch of numbers, you got to follow the order of operations rules. And maybe the one that I always kind of watch out for is something, oh, and I'll even put an exponent in there, right? It's something that looks like this, but I usually like to point out is this little 6 minus 4 right here. It looks like, oh, that's an easy thing I can just put together, right? 6 minus 4 is a 2, even if especially if I didn't have the exponent there, right? But no, that's really 4 times whatever I'm going to get over here. That would be a multiply before I do subtraction. Don't try not to fall into that mistake, okay? So really the first thing, here's 2 levels of groupings. So the first thing I need to do is go to the innermost grouping and simplify inside there. I usually advocate don't change anything else yet. And I don't really need the parentheses anymore, so I wrote it like that, 4 times 10. You could leave it in parentheses if you like. Now, that grouping is resolved. Are there any exponents inside? Yeah, I made that one there. Just do the exponent. You can maybe say, well, I could do the 4 times 10, but I'm being real careful. All right, so now inside still, do the multiply. That 3 is just waiting for the very last step on the outside. 36 minus 40. There's the last thing to do inside. 3 times 36 minus 40, a negative 4. Notice I used some parentheses there now because it's a negative number. And I'm going to get a negative 12. So that was simplifying an expression. All numbers, right? It can be reduced down to a single value eventually. And let's see, I'm going to make up another one, okay? I made a fraction order of operations problem. Remember, the fraction bar is a grouping symbol. Do everything on top first, do everything on the bottom second, you know, whatever order, but simplify one part and then simplify the other part, and then just look and see what more you might be able to do to the resulting fraction. So in the numerator, no real groupings, but I have an exponent. And this is really separate. You okay with I just went to 25 minus 12. That's really multiply, isn't it? 5 times 5. And in the denominator, I do have a little grouping here. I'll show lots of steps. 8 minus 1 is a 7, huh? Now, next step. I'm doing the top and bottom separately, so if I'm ready to do something else in the numerator, I can do it. 25 minus 12, that's a 13, huh? That number's done, waiting for whatever I get in the denominator. What's 2 cubed? I ask that just so you realize it's 2 times 2 times 2, and now 2 times 3. Not a 6, it's an 8. Watch out for that kind of thing. And so that's going to be 13 over 15. And then you look and say, can I reduce that? Not this time. Right? So there's an order of operations problem that was built up inside of a fraction. Let's see, here's one that you've already done this kind of problem, sort of. I'm going to make up a couple numbers because I don't know these exact numbers off the top of my head. And I'll cheat and say the highest point or elevation nearby is 6,300 feet. The lowest is minus 50 feet. You know, elevations are based on sea level being 0. Mountains, you go up really high, and like Death Valley, you go down. If you've ever been there. Just hot desert, but you're below sea level. What's the difference in elevation? Floppy. What's the difference in elevation? Now, you might be able to just reason this out, but writing a equation is kind of what we're hoping you will do. I also kind of, for elevation problems, I kind of like drawing a picture, like up and down timeline. Oh, this one I'm up to 6,300. Then I'm down to minus 50. From the picture, I can see, oh, the difference is like I'm going to add those two amounts, kind of. At least that's what maybe it makes sense when you see it. But a difference, that's a subtraction problem, isn't it? How does that work? 6,300 minus a negative 50. What do I do if I get minus minus? I'm adding, right? So it does turn into this number plus that number. Now I get 6,350 feet. If you really were faced with a problem like that, watch out for units. Again, my open math's been pretty nice to you. Put the units in already, a lot of them. At most, I think it'd give you a drop-down menu and you have to pick the right units. I bet something like area or perimeter might give you a menu like that. And then you have to remember area is always squared and volume is always something cubed. So you've done problems like this with temperature. Like it started out at 75 degrees and it dropped to 35 degrees. What was the difference in temperature? 75 minus 35 get you your 40 degrees. Here I purposely went from positive to negative. It's still a minus, but minus a minus, you get that bigger number. I usually, in the past when I've had to write my own tests, I usually use some version of this at some point, maybe even the final or something like that. You know? The final, well, most all of these tests actually, the tests in WOM are generated, just like I mentioned, each problem is a little different for each student, which all see the same kind of problem, some similar kinds of numbers. I think, yeah, our final exam is the same, but our department picks the questions based on basically the coordinator who put together all these tests for our course. But every Math 60 class will be taking the same final exam. That way, you know, we're all expecting you to achieve the same level at the end of the term. Let's do simplify that expression using the distributive property. Purposely put a negative sign out front. Remember to distribute the negative to both terms. So it's -3 times the first one and -3 times the second one. Whatever you get. So I get -3x and -21. All right, distributed that negative sign. A little bit longer one, but the same kind of problem. Simplify this using the distributive property, or eventually the instructions just kind of say simplify. That means I've got to use the distributive property to do that. So there's a multiplication. I'm going to do 2 times all of that. Here's a separate multiplication, really, -4 times all of that. So it's 2 of these things, but I'm going to use -4 times both of those things. So this one turns into 6x minus 14. And I'm going to attach that negative. I'm really subtracting 4 of all of those. So -4 times each of those, minus plus 8x, minus times positive is minus 36. Now we continue to simplify by combining like terms. Are there terms with the same variables and exponents? Yep, I got a bunch of x's I can put together. So there's 14 of the x's, minus 14 and minus 36, minus 50. Can't put them together any further. Ta-da. Feel free to jump in and say, oh, be sure we do blah, blah. How about a little, let's Let's see, convert. Conversion problems aren't big and long and tricky. I'll just tell you that. Convert that number of feet to miles, and then you get you're given the conversion. It's written right into the test. This is what you need to use. Okay. So how many miles is that many feet? Well, you might think, oh, that's less than one. That means I could divide. And that really is going to be what we end up doing. I'm going to use this process I've used consistently. I'm going to take my original number of feet, include your units when you set it up. The units are what help you do this correctly. Set it up with the units. And I always make a fraction over 1 of that first number. And I know now I'm going to use some version of that conversion so that I end up in miles. Remember my technique here, process. This could be a fraction one way or the other. I want the version that's going to have feet on the opposite side so they cancel out. That puts the miles on top. And if the feet cancel, I'm left with just miles, which is what I'm after. So 1 mile, 5,280 feet. And now I'm ready to do the math. And oh yes, it is a division problem. And you do get to pull out your calculator. Do that right now. Here we go. 3260 divided by 280. And I'm pretty sure your test questions tell you to round to so many decimal places. So remember rounding, you always look one more and that decides whether you round up or down. Like right now, mine says 0.6174 and a bunch of extra stuff. I'm going to round to 2 places, right? Or the hundredths place. You might be expected to know the place value, tens, hundredths, thousands, right? If I round to the hundredths place, I'm going to round to the second. That means I'm going to test, look at the 7. The 7's closer to going up to 2. 62 miles. Okay. Kind of talk about a lot of things right there at the end, the rounding. Right? Make sure you're comfortable with that rounding process. Let's see. I'm going to do one more, okay, of those. And if you're given a metric conversion, again, you'll get the conversion right there. Sometimes I think they're easy if you're just doing the metric. I don't think we ask you to go between units, but even so, if I ask you to go from miles to kilometers, you get that conversion. You set it up just like that. I'm going to see if I can make up something. A tank drains at a rate of, let's see if I can make something reasonable. What is the rate in quarts per minute? We'll see it probably in words, but I'm writing the sort of fraction rate shortcut here. A tank is draining at a rate of 250 gallons per hour. Kind of slowly draining, all right? What is that rate in quarts per minute? Oh, I'm changing from one rate, 2 units, to another rate, 2 different units. You will be given the conversions. So 1 gallon equals 4 quarts, and 1 hour equals 60 minutes. So this is as tricky as it would get. You might have two kinds of, you might have a rate that could change. So I always start with a given number, kind of like make a fraction out of it. 250 gallons per 1 hour. I just always kind of put the 1 in, but the gallons per hour, that fraction bar is that word per when we think of it like that, miles per hour. And now I'm going to have to do gallons to quarts, and I'm going to have to do hours to minutes. I can think of the different pieces, you know, so I'm kind of like setting up. I know I got to fill in these blanks. And so I end up with quarts per minute. All right. It doesn't matter which one you do first. I could do the time and then the volume, or I could do the volume and then the time. How about, so gallons opposite puts quarts on top. Hours are on the bottom here. So hours opposite would be on top over here and minutes on the bottom. Gallons will cancel each other. Hours reach over, cancel each other, and I'm left with quarts over minutes. That's what I want. 1 gallon, 4 quarts. 1 hour, 60 minutes. The units get you in the right orientation, then make sure you get the correct number in the right place. So now I'm ready to do the calculation. Multiply, 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 divide, divide, divide. In my calculator, I'm going to do 250 times 4 divided by 60. Anything on the bottom, I divide by. Anything on the top, I divide by. There was another number in here, I'd say divide by 60, divide by something else, divide by something else. Here I go. And, well, 250 times 4 divided by 60. And I'll round 2 places again. I've got 16.67 quarts per minute. Two different units, you get the conversion, set it up the right way. Otherwise, you'll be asked to do something more, I call it simpler, you know, change from this 1 unit to this other 1 unit, something more basic. Okay. The last group of topics that we covered, the geometry things. Yeah. And hope my forum response regarding the hand-in homework worksheet was helpful. When you're doing those geometry problems in my open math and then hand-in homework due tonight, right? You know, so you get those combinations that you got to figure out, what is that figure really? You know, we had some in the review, kind of looks like this, right? You have a square with a triangle. That one in the hand-in homework, right? You take all those semicircles and put them together. That makes 1 circle, that makes 1 circle. You get 2 circles. That was my big hint there, right? It's got 1 square plus 2 circles. Figure out the combined areas there. A couple questions about that. Right, perimeter. I have this kind of shape. And I call that 12. You know, what's the perimeter and what's the area? And let's call them all feet, okay? What's the perimeter and area? You okay with that, or do you really want me to finish it? Yes, please finish. I'm getting just examples, right? Or here's a circle, and I know the diameter is 10 inches. What's the circumference and the area of that circle? You will have either the formulas in the question If you don't have the formulas in question, you can pull out your geometry formula worksheet, but you should have that pi r squared or circumference equals pi times diameter or 2 pi r. You should have those formulas in the questions. Again, you can pull out your geometry worksheet if you need to, okay? Again, do I need to finish that up for you? You're okay with that? You understand how to do that? This one, you know, you've got to figure out, oh, this must be the difference, that must be an 8, and this must be a 9. If I'm going to do the area, I got to chop into 2 pieces. Here, remember, if I'm going to do the area, I need to know the radius, pi r squared, the radius squared. I need to half the diameter to get the radius. And maybe you would be asked to do something not too weird. We don't want you to take an hour. You know, if they had to figure out the area of a figure like that, of course, you'd have to be given necessary information. Could you figure out the area of that figure? A triangle plus a square. I made it a square. I guess it could be a rectangle, but you know, find the area of the square separately. Use the formula. Find the area of the triangle separately. Go from there. I'm kind of down the end of my list here. So if you want me to do something else specifically, let me know. Otherwise, I think we're going to stop in a minute here. Of course, if you're working through reviews and stuff, anything all day today, you know, I'll be checking in and get back to you today. Do my very best. You know, I know students, you young folks, many of you stay up late and do your work. You know, I'm usually sitting in bed reading by 9 o'clock. So don't expect me to reply to you much, you know, after about 8:30 or something like that. If you need some help, try to reach me sooner. I did mention also in my email this morning, my message, because it's test day and somebody could be taking the test at any time of the day, we'll have no class. I couldn't be standing here and doing this kind of thing tomorrow, answering questions for you, and somebody's on the side kind of watching, you know, answering test questions. So there'll be no Zoom class tomorrow. Anybody else? Yes, Tara. Again, go ahead.
Where will the test be on?
Yes, and it's always hidden until the day of. So right now, if you were to look on the main page of My Open Math, right below week 2, there's test 1 information. There's a bar, a block for that. And I believe the test itself will show up immediately below that, right there on the main page. And then, you know, it'll be the test. And then right below that, the scratch paper, just like a homework pen and assignment. It'll be right there. Okay. All right, folks. Well, I always kind of feel like there's so many little pieces, and you know, getting started is, you know, the flow's always rough. I'm always glad to get through the first test and hope that you do well. And kind of good luck. And
I have a quick question about the test tomorrow.
yes, go for it.
I noticed, you know, like in the homework, we're allowed multiple tries on our questions when we're doing it, and you know, if we get it wrong, we can try again and again. Is the test going to be set up the same way, or do we just get one try on the answers?
You get one chance. That's why it's kind of
Okay.
different. You do it all out on paper. You get your final answer, then you enter your answer, and the way the program is set up, you enter all your answers. You can even go to the drop-down menu and do questions out of order, but don't click submit until you're completely done. All right. You put all your answers in, move to question to question to question. And when you find, I think, like I said, I think you can actually pause the test, but it's still, the clock's still ticking. You still only have an hour, even if like you walk away. But yeah, the final thing to do is click submit. Okay. I'll kind of be watching, checking in a little bit just to see who's doing it or who's still left. If you really have a procedural question, send me a message or send me an email, okay? But I can't say anything about how to answer a question, how to do a certain kind of question. But if something doesn't make sense, how to do it, I mean, mechanically in the program, let me know. All right, Okay, folks, well, work through that review. I think that's, if you're comfortable with that review handout, that's, you're gonna be well prepared. All right. Well, good luck then, and I'll see you Wednesday. And, well, okay. Take care. Bye. Marlena, I did see your sample, what did I call it? A homework practice scan. You know, just see if you're getting comfortable with that practice scanning and homework. I did see that. Thank you for the picture. All right, guys. See you in a couple days. All right. Okay. Bye.